Okay, lesson 109 is about simple interest and compound interest. First of all, let's just talk about what interest is. Interest is money that the bank might pay you if you put your money in the bank in a savings account specifically. The bank will basically pay you interest on that so that they can loan out that money that you've put in the bank in the savings account at a higher interest rate to someone else who wants to borrow. Interest also comes into play when, say, you have a credit card and you don't pay off your balance. They will charge you interest on that, usually much, much, much higher interest than you would ever earn at a bank. So that's why credit cards can be so dangerous because, as you can see, interest builds up. And so credit card fees and interest on balances can climb extremely fast. So that is something to be aware of and to be careful of. So simple interest is basic. Simple interest just says, I put in a certain amount of money and I don't take any of that money out, and I earn a certain percentage on what I put in. Okay, so let's just look at our first example and work with that. So Jim put $5,000 in the bank for 2 years at 8% simple interest. I always like writing down the information I have. Okay, so that means each year he earned 8%. So we could find out how much he earns in 1 year by multiplying by 8%, but change 8% to a decimal. Now remember, percent means per hundredth. So 8% is the same thing as 0.08. So if we multiply by 0.08, we get $400. So after 1 year, he earns $400. Well, it tells us that it's in the bank for 2 years. So that would mean he earns $800. So at the end of 2 years, he had $5,800. That's simple interest. Okay, compound interest is something more like our third example. It says, how much will $700 be worth in 2 years if the money is deposited at 9% interest and compounded annually? So we have $700. Okay, and what we could do is we could multiply by 9% or 0.09. But that'll only tell us what the interest is. If we multiply by 1.09, that will include the $700 that we started with. Okay, so that just kind of makes the addition happen in the problem, so we don't have to think about it separately. So that's 63, and then placeholder 0. Actually, we have 2 placeholder zeros and a 7 here. So that's $763 at the end of 1 year. So the way compound interest is, now we can use this new balance and we can earn interest on the interest we earned last year. We can earn interest on that in the second year. So once again, multiply by 1.09. 9 times 3 is 27. Carry the 2. 54 plus 2 is 56. Carry the 5. 63 plus 5 is 68. All right, so you can see already we would have our decimal point there. If we were just finding the interest alone, it would be $68.67. But we are going to include our principal which is the amount that was already there. So after 2 years, we have $831.67. Okay, so obviously compound interest is way better for the investor. And when it's a debt that you owe, you end up paying way more in interest that way. But if you're an investor and you can earn a high interest rate, if it's compounded annually, it's way better than having simple interest. Okay, finish up those practice problems. Lesson 110 is about markups and markdowns, or you might call them markups and discounts. So these are used in retail stores frequently because when a store owner sets up his store, he needs to buy things in bulk and then sell them off for a profit. So when you go to the store, when you buy an item, say from Target, you are paying for the overhead of the building. You're paying for the electricity and water of that building, the cleaning of that building, and all the people who work in it. So all of those costs are captured in the markup. And that's why stores like Amazon have been so disruptive, because they need warehouses and they need workers, but they don't have a retail shop. So that does decrease the cost they spend on their overhead. So let's look at the first example I have. Mr. Franklin bought new dresses for $40 each. He marked each dress up 150%. What was the price he charged his customers? Well, there's more than one way to figure this out. So if you think about it, he bought dresses, say from China, for $40 each. And then, so what if he marked them up 100%? I know that it says that he marked them up 150%, but let's just say he only marked them up 100%. What would be the cost? $80. What if he marked them up 50%? They cost him $40, and he marked them up 50%. Well, 50% is half of 40, so he marked them up 20, so that means it would be $60. Okay, but he actually marked them up 150, so 150% is going to be the $40, that's the 100% markup, plus the $20, that's the 50, so a total of $60 markup. So what does that mean that each dress costs? Well, each dress is going to cost $100. Let's do it just using multiplication. So what is $40 times 150%? Well, 150% is 1.5. And we can have that extra zero, but we really don't need it, do we? So let's just take that zero off and multiply. 5 times 0 is 0, 5 times 4 is 20. Put a placeholder 0 in, and 40. So that's a $60 increase. That doesn't include the actual cost of it. If we wanted to include that cost, we would have had to multiply by 250, 2.5. Okay, so $60 represents the markup, and $100 is the actual cost to customer. it's important that you understand what all of these numbers, where they're coming from, and what they mean, obviously. So let's do a discount, because those can be a little bit tricky. Let's take a look at the fourth box. It says the suit was marked down 20%. For the sale, and its sale price was $120. Okay, so what they're trying to figure out is what is the original price of the suit. Well, let's take a look at it. So 20% represents the discount. Okay. So 100% was the original cost, right? And so 80% represents what? Well, that represents the amount paid by customer after the discount. The customer is paying 80%. So if you think about it, 80% of the original cost equals $120. Okay, so we can now take this and create an equation out of it, because we know what of means. We know to change a percentage to a decimal. 0.8 of means multiply. Original cost, that's what we're looking for, is equals $120. And now we divide both sides by 0.8. We had to add an extra 0 because we had to move that decimal point. It goes into 12 once. Okay, so our original cost was $150. So that means our discount was $30. But the question is, what was the original price of the suit? And the original price was $150. Do the rest of the practice problems on your right. Lesson 111 is on commission and profit. So these last three lessons are really, they do go together well, because they're all about increasing dollar amounts or decreasing dollar amounts. So my first question is, what is commission? So commission is a percentage paid to a salesperson. So let's say you go to a car lot and you want to buy a car. Well, that salesperson is going to make a certain percent off of what you buy. So if you buy an expensive car, they get a bigger paycheck. Okay. Profit is income a business might receive after all expenses have been paid. So you have to subtract off, as we were talking about in the previous lesson, you have to subtract off the cost of the building, the cost of the electricity, the cost of the original product, and all of these expenses that go into running a business. All right, let's look at the first example. It says a sales rep was paid a base salary of $300 a month. That's not much, is it? Okay. Per hour, if you're working $40 an hour, 40 hours a week, that's a very low. That's below minimum wage. But he was also paid a commission of 10% on everything he sold. Okay, 10% commission. So if he sold $26,000 worth of merchandise in 1 month, how much did he earn? What was his paycheck? So if he sold $26,000 worth of material, well, he gets 10% of that, which would equal, just dropping 1 zero off, right? $2,600. But he also gets his $300 a month regardless of how much he sells. So altogether, he gets $2,900. Okay, let's look at number 4. It says a store owner purchased $200,000 worth of merchandise and sold it at a markup of 4%. If his expenses totaled $5,500, what was his profit? Okay, so all we're looking for is the markup, because he had to spend $200,000 on this, whatever he bought, whatever merchandise he's selling. So all he gets is the 4% minus these expenses. So what is 4% of $200,000? All right, we have 2 decimal points, so it goes here. So on that merchandise, he made $8,000, but he has overhead. He has these expenses, so we have to subtract those. $5,500. So overall, he just made $2,500. Okay, lesson 112 is about probability, and this is just part 1. All right, so probability is the likelihood of something occurring. So if something is more probable, the probability will be closer to 1, and if it's less probable, it'll be closer to 0. All right, so that's what all probabilities range between 1 and 0. All right, so there are a few things you need to know, and our family is a game-playing family. So we know this, that there's 52 cards in a deck with 4 different suits: spades, hearts, diamonds, and clubs. And so there's 13 of each kind. Okay? So let's say that Jimmy tears up the ace of spades and shuffles the remainder of the deck and draws 1 card. What's the probability that the card is a spade? Well, there were 52 cards, but now there's only 51 because he tore up the ace of spades. Okay, and he wants to know what's the probability that the card's a spade. Well, how many spades are there now? There are only 12 spades. And we calculate probability by dividing the number of outcomes for the test. In other words, for this one, it's spades, divided by the total number of possible outcomes, 51. Now, what we can do at this point is we can look to see if we can reduce this fraction. And you got to remember how we know about divisibility. So are these numbers divisible by anything that's the same? Do they have the same factor? Well, 5 plus 1 is 6, which means that 51 is divisible by 3. So we can divide each of these by 3. So that yields 4 over 17. Okay, this is the probability of the outcome. You always want to reduce when you can. All right, so another thing about probability, so we use cards, we use dice, we use dice a lot. We use marbles. Okay. So right now all the questions are going to be pretty simple, but you really need to be able to understand this chart that's in your notes, and it's not super easy to read on my screen, so you definitely want to look at your notes. So I'm just want you to understand what they mean. So they might say, what's the probability that you'll get the sum of 2? Well, there's only one way to get a sum of 2, right? You have to roll 2 ones. And how many total possibilities are out there? Well, this is a 6 by 6 cube, so, or 6 by 6 square. So you know that there's a total of 36 options. So there's only one out of 36, one way out of 36 to get a 2. But let's say you wanted to know what's the probability that you would get a 6. Well, you could get it. Any of these are options, right? So that's 1, 2, 3, 4, 5. So you have the probability of 5 out of 36 for rolling die that have the sum of 6. Okay, so that's what these numbers here are. Inside the square, these are the sums you can get when rolling 2 die. Okay, and these are the die. So if you're going to get a 6, you might get a 6 by rolling a 5 and a 1, or by rolling a 4 and a 2. Okay, or by rolling a 3 and a 3, or a 2 and a 4, or a 1 and a 5. Okay, I've just found that people sometimes don't understand how to read this chart, and this chart's really important when you're doing probability problems. So you want to be able to reproduce that because it will help you on your exams when you take tests. Okay, so the primary thing to remember at this point is that probability is the number of outcomes for the test divided by the total number of outcomes. And we'll definitely go over these together in class. So I'd like for you to try to do them on your own, and I'm sure you won't have any trouble with it. I want to see what you can do and see what you have.